Let us talk about computer memory and storage units. Memory is where the computer stores data and instructions. Without memory, the computer cannot remember anything. It would have to start over every time you turn it on. This is Topic 4. We are discussing computer memory and storage units. By the end of this lesson, you will understand the different types of memory, the hierarchy of memory, storage units and their conversions, and how to answer exam questions. Take your notes. Let us go. First, what is computer memory? Computer memory is the electronic components that store data, instructions, and information for use by the computer. Memory is essential for the computer to function. It holds the programs that are running and the data that is being processed. Without memory, the CPU would have nowhere to get instructions from or put results. Memory is measured in bytes. A byte is the basic unit of storage. 1 byte can store one character, such as a letter, number, or symbol. Now let me explain the hierarchy of memory. Computer memory is organized in a hierarchy from fastest and most expensive to slowest and least expensive. At the top of the hierarchy are the CPU registers. Registers are tiny storage locations inside the CPU itself. They are the fastest memory but also the smallest. They hold data that the CPU is currently processing. Next is cache memory. Cache is very fast memory located close to the CPU. It stores copies of frequently used data to speed up processing. There are different levels of cache: L1, L2, and L3. L1 is the smallest and fastest. L3 is larger but slower. Next is primary memory, also called main memory. This includes RAM and ROM. Primary memory is directly accessible by the CPU. It is faster than secondary storage, but slower than cache. Next is secondary storage, also called secondary memory. This includes hard disk drives, solid-state drives, and USB flash drives. Secondary storage is slower than primary memory but has much larger capacity. It is non-volatile, meaning it retains data when power is off. At the bottom of the hierarchy is tertiary storage. This includes magnetic tape and optical disks. It is the slowest and cheapest. It is used for backup and archiving. Now let me explain RAM in detail. RAM stands for Random Access Memory. RAM is the main memory where the computer stores data and instructions that are currently in use. RAM is volatile. This means that when you turn off the computer, everything in RAM is lost. That is why you must save your work to secondary storage before shutting down. RAM is called random access because the CPU can access any location in RAM directly. It does not have to go through other locations. There are different types of RAM. DRAM stands for Dynamic Random Access Memory. It needs to be refreshed thousands of times per second to hold data. It is used as main memory in most computers. SRAM stands for Static Random Access Memory. It does not need to be refreshed. It is faster, but more expensive. It is used for cache memory. SDRAM stands for Synchronous Dynamic Random Access Memory. It is synchronized with the CPU's clock for faster performance. DDR-RAM stands for Double Data Rate Random Access Memory. It transfers data twice per clock cycle. There are different generations: DDR2, DDR3, DDR4, and DDR5. Each generation is faster and uses less power. Now let me explain ROM. ROM stands for Read-Only Memory. ROM is non-volatile. It retains its contents even when the computer is turned off. ROM is read-only. The CPU can read from ROM but cannot write to it. ROM contains the basic instructions that the computer needs to start up. These instructions are called the BIOS, or Basic Input-Output System. There are different types of ROM. Mask ROM is programmed during manufacturing. It cannot be changed at all. PROM stands for Programmable Read-Only Memory. It can be programmed once by the user. After that, it cannot be changed. EEPROM stands for Erasable Programmable Read-Only Memory. It can be erased by exposing it to ultraviolet light and then reprogrammed. EEPROM stands for Electrically Erasable Programmable Read-Only Memory. It can be erased and reprogrammed using electricity. Flash memory is a type of EEPROM that can be erased and reprogrammed in blocks. It is used in USB drives, solid-state drives, and memory cards. Now let me compare RAM and ROM. RAM is volatile. ROM is non-volatile. RAM can be read from and written to. ROM can only be read from. RAM is used for temporary storage of running programs and data. ROM is used for permanent storage of startup instructions. RAM is larger in capacity. ROM is smaller. RAM is faster. ROM is slower. RAM is more expensive per byte. ROM is cheaper per byte. When you turn off the computer, RAM is cleared. ROM stays the same. Now let me explain storage units. Storage units are used to measure the amount of data that can be stored. The smallest unit is the bit. A bit is a binary digit. It can be either 0 or 1. Bits are the basic building blocks of all digital data. A byte is 8 bitses. 1 byte can store 1 character. For example, the letter A is stored as 1 byte. A kilobyte is 1024 bytes. It is often rounded to 1000 bytes for simplicity. 1 kilobyte can store about 1 page of text. A megabyte is at 224 kilobytes. It is about 1 million bytes. 1 megabyte can store a small novel or a low-resolution photo. A gigabyte is at 224 megabytes. It is about 1 billion bytes. 1 gigabyte can store about 250 songs or 500 photos. A terabyte is 1024 gigabytes. It is about 1 trillion bytes. 1 terabyte can store about 250 movies or 200,000 photos. A petabyte is 1024 terabytes. It is about 1 quadrillion bytes. Large data centers store data in petabytes. An exabyte is 1024 petabytes. Zettabyte and yottabyte are even larger. Let me give you the exact conversions. 1 byte equals 8 bitses. 1 kilobyte equals 1024 byteses. 1 Megabyte equals 1024 Kilobytes. 1 Gigabyte equals 1024 Megabytes. 1 Terabyte equals 1024 Gigabyte. 1 petabyte equals 1024 terabytes. 1 exabyte equals 1024 petabytes. You need to know these conversions for your exam. For example, to convert 4 gigabytes to megabytes, multiply 4 by 1024. That gives 4096 megabytes. To convert 2048 megabytes to gigabytes, divide 2048 by 1024. That gives 2 gigabytes. Now let me explain the difference between storage and memory. People often use these words interchangeably, but they are different. Memory usually refers to primary memory like RAM. Storage usually refers to secondary storage like hard drives. Memory is fast but temporary. Storage is slower but permanent. Memory is measured in gigabytes. Storage is also measured in gigabytes but can be terabytes. When you run a program, it is copied from storage into memory. The CPU can only access data that is in memory. That is why having enough RAM is important. If you do not have enough RAM, the computer becomes slow. Now let me explain how data is stored on magnetic and optical media. On a hard disk drive, data is stored on spinning magnetic platters. The platters are coated with magnetic material. The read-write head changes the magnetic orientation of tiny regions to represent 0s and 1s. On an optical disc like a CD or DVD, data is stored as tiny pits and lands. The laser reads the reflection. Pits scatter light and represent 0. Lands reflect light and represent 1. On a solid-state drive, data is stored in flash memory cells. Each cell holds an electrical charge. The presence or absence of charge represents 0 or 1. A common exam question asks you to distinguish between RAM and ROM. Here is a sample answer. RAM is volatile memory that loses data when power is off. ROM is non-volatile memory that retains data. RAM can be read and written. ROM can only be read. RAM stores running programs and data. ROM stores startup instructions. RAM is larger and faster. ROM is smaller and slower. Another exam question asks you to convert between storage units. Here is your answer. To convert from a larger unit to a smaller unit, multiply by 1024. To convert from a smaller unit to a larger unit, divide by 1024. For example, 3 gigabytes is 3 times 1000, and 24 equals 3072 megabytes. 2048 Kilobytes is 2048 divided by 1024 equals 2 megabytes. Practice these conversions until they become easy. Another exam question asks you to explain the memory hierarchy. Here is your answer. The memory hierarchy from fastest to slowest is CPU registers, cache memory, primary memory, RAM and ROM, secondary storage, hard drives and SSDs, and tertiary storage tape and optical disks. Faster memory is more expensive per byte. Slower memory is cheaper. The hierarchy balances speed, cost, and capacity. Here is what you need to take away. Computer memory is organized in a hierarchy. RAM is volatile and used for temporary storage. ROM is non-volatile and used for permanent instructions. Storage units are bits, bytes, kilobytes, megabytes, gigabytes, terabytes, and larger. Conversions use 1024 as the factor. Memory is different from storage. Memory is fast and temporary. Storage is slower and permanent. Practice these concepts. When you have them down, move to topic 5.